Hello friends, today we are going to go through an example of Openstaad using macros, the connected edition of Stad. So they have provided in the developer tab the macro editor and the macros. So if we click on macros, we get this pop-up and we can import a macro. This in this way you can import a macro, but we have to write a macro also. Being a structural engineer, we don't have much exposure towards software engineering to write a VBA code, even though we have learned it in our structural engineering syllabus in the engineering course. But we should use such tools to simplify our design process and reduce our time and efforts. Sometimes for this example I've taken a structure where we can see that it's a simple structure. This is the main beams, these are the secondary beams, these are the tertiary beams. So in this case this is just a plan bracing, this is the elevation bracing, the columns. This is a small structure, but when the structure is quite big enough, say 300, 400, 500, 600 tons of structure, so in that structure if we want to check if the member sizing is correct or not, so in that case it becomes difficult. So due to the presence of nodes in these members, it all becomes jumbled up and we can't actually see which member is connected to which member, and is it sizing is correct or not. Suppose this IP 450 depth is connected to 500 depth, this is simple shear connection beam, so it is okay. So in this case you can see this tie beam, but IP 240 depth connected with 450, okay. But here there is some mistake in this modeling, or something mistake has happened. This HE 500 is connected on IP 450. So such checks are important so that such silly mistakes don't happen and don't propagate towards the modeling. So it increases efforts in the both sides. How do we tackle these issues? This is a simple plan and structure. It is easy to identify, but in a big structures it is very difficult to, if hundreds of beams are somehow need to be checked, it takes a lot of time and effort. So what we can do is we can develop macro. I'll have prepared macro. I will just import it and show it to you. This member size check. Okay, so I will just show you. If secondary simple beam more depth than main beam, this is a check. So it takes some time at my system to open up. For developing macro you just need some logic, that is if else statements, for loops, those are enough. And the Openstaad manual, that is the help uh, manual, is available from the stat file itself. I will show you that also in a bit a moment. This is just the syntax, the old code. Right. This is the whole code within the macro to check if second simple beam is more than the main beam depth. Okay. We call this message box, please wait for macro to complete the task, because it takes some time for the macro to run. We have mentioned it as an information only. Then this is just a declaration of the variables, the index, that is the total length of the array, how much size of the array we should declare. These are the basic code requirements of the VBA script. And then we get hold of the statpro object, we get hold of the file folder path of that stat. Then we have an option to save whatever we have uh, extracted from the stat as an output in a text file. So this way we can open this file folder text file and output it as number one. We will reference this number one later and write to it using the print command. And then this is we start our extraction of, say, to get the member count. This is the function object openstaad geometry get member count. This is a function of openstaad. We are accessing the get member count of the total number of beams. So and we store it in beam number array. This is the size. We redeclare it. Okay. Then object openstaad geometry get beam list beam number array. Here we get the beam list and store it in beam number array. And then we go into a for loop for all the beam number arrays. We store it in I beam number, and we run our code from here. Initialize. This initialization is required, we'll get to it later. And properties get member release specification. L beam number, that is the beam number, 0 is the start and 1 is the end side of the beam. Okay. I release array, this is the release member specification. So we will get this release specification, and the mz we are going to extract. So for mz it is number 5 index. Okay. And if that is greater than 0, that is it will show 1 if it is mz is given, for release is given in this beam. So we need to check if it is greater than 1, that is greater than 0, that is 1. So we will run this code. If this, then this. Okay. This is incidence. This is again, these are all the openstaad functions. You will if you go into the help menu, you will get hold of all these functions, and you will get to read about it in detail, and in the summary they will you will understand what is input, what is output. So here we give the input IB number, we get this as output, n node A, n node B. We have mentioned it earlier, n node A, n node B as long. So it will give us the n node A and n node B integers values. Okay. And store it in n node A, n node B. Then I am also accessing the gate beams connected at node and n node A. Okay. And store it in start connection beam list array. Okay. Similarly for end node, end connection beam list array. Okay. Then again, number of beams at node A, number of beams at other end at node B. Okay. So I'm getting property, so that we need to find the depth of the original. I have given 0 for the original beam, that is the secondary beam, that we are going to check if the size is lesser or equal to or more than the main beam. Okay. For the secondary beam, the depth 0 will get, and the coordinates for node A, node B is 1 2 1 2 1 2. Okay. X y z. Then again, if we'll check if it is column, that is if it is a column and connected, the beam is connected to a column, we're going to ignore it, because it is not a beam to beam connection. So that end we are going to ignore. So we are exiting the for loop if it is true. Similarly at the other end, the next we are going to check if that is false, that is it is not connected to a column and it is not the same beam. The beam that we are going to check are the beams that are connected to the start and end nodes of the secondary beam, that is the main beams. This is the code we will be running for the main beams to check their depth. This depth is the depth of the main beam, and this is the depth of the secondary beam. So this, if this equation satisfies, then we run this. Okay. This is a string, this we are appending to the string the beam number, so that we get the list at the end of the program. Okay. This beam number gets added to this string, and it gets overwritten with appending this beam number as it gets processed. So many beams will get processed. Okay. The list will get formed easily. And this print number 1, the hash 1 that we talked about earlier. So we print this beam, start connection beam, this beam id will get with depth so and so, and on this beam, this vbcrlf is to go to the next line. Okay. So these are all conditions that we are going to check. This we are going for x, this we are going for z direction. Okay. And similarly, this was done at the start end of the beam. Okay. Then again the same thing happens at end I, that is end, that is 0 is for start, 1 is for the end side of the beam. The same code, only the difference is end connection beam list array we are going to use here, here, here. Okay, the code is similar for both the nodes of the beam. And then we end the for loops, end the if else statements, and print to the file path. If it is empty, so we have passed the check and there is no beam which is greater than the main beam depth, no secondary beam depth which is greater. But if it is the scene where secondary beam number are more depth than main beam, we will get the beam numbers which are being appended as a list. Okay, so we'll just run this code. I will, for the time being, I will not require because it will take some time. Okay, so we will close this. I can copy these beam numbers, I can go to select, I can select these beams. These beams, as you can see, are more depth than the main beams on which they are resting. So we are successful in making this macro, and it saves us great time and effort. And it also opens up a new way of possibilities for much more developments and tools, small tools that can help us save time and money. Time is money. Yeah. Okay, so I'll just show you what text file it generates. This is a text file that it has generated, and it has given what beam depth is resting on which beam depth. So you can meticulously check if it is okay, then you can ignore, or you can select these beams. We have also mentioned the path. This is a shorthand path, so it is not, it won't be the actual path, but you can just refer this and reach this text file. It will be the same path as the staad file, because it has been designed in such a way, it has been coded in such a way. So you can select these beam numbers, and you can also visibly check. See, this was the beam and this is the other beam. Yes, currently this works on simple beams resting on the main beams. Okay, this is a simple beam, this is a simple beam, and the beam which is not connected to a column. So beam to beam connections we are testing. Okay, and parallel to x and parallel to z axis of the staad. So if it meets these requirements, we can easily check. Yes, so feel free to add some comment. Thanks, see you soon.